Here's 2017 question 1. This is a Riemann sum problem for the most part, because you can tell there's a table there, okay? And just by skimming through it. Here we go. Use the left Riemann sum with 3 subintervals indicated by the table to approximate the volume of the tank. Okay, so notice here how they ask for units of measure. Right away, if I'm approximating volume, I know my units are going to come out to cubic feet because volume can only be measured in cubic units. So just keep that in mind, okay? Okay, left Riemann sum. So horizontal distance, which is 2, times the left endpoint, 50.3, plus horizontal distance, that's 3, times the left endpoint, which is 14.4, and last one, 5 horizontal distance, left endpoint is 6.5. That's enough for equal is equal there. Let's move on to part B. So this one pops up occasionally, okay? They ask if your approximation is an over and under estimate. So remember, you need 3 clues. Okay, you need to tell me if it's over or under, what type of Riemann sum, and the direction of the graph. So they have to tell us somewhere in this text what's happening to the area, okay? So A is what we're looking at, okay? But also if you take a look, it says it, I'll highlight it right here. The function A is continuous and decreases as h increases. So you got to read that very carefully. So they're saying that A is decreasing as h increases. So which one is it, right? So they're saying as h increases, meaning if you move towards the right, A is falling downwards. So we now know that it's a decreasing function for a left Riemann sum. So the only thing is this over or under? I personally don't remember, so I always draw it out. Let's draw out any type of decreasing function. It doesn't matter with the concavity, okay? So if I draw left endpoints, left Riemann sums, you draw enough to tell that this dips above the graph, so we know it's going to be an overestimate. The only way to earn this point is if you mention all 3, okay? Here's part C. They introduce a new function f of h, okay, which represents the area of the cross-section. Based on this model, find the volume of the tank. Okay, so how do you go from area to volume, right? How do we do that? So let's see. So if we integrate area, we're going to get volume. Just think about it this way. If you integrate something that's squared, you get something cubic, right? So if we integrate f of h with respect to h, from 0 to 10, according to the table, we'll get our answer here. I think it comes out to like 101 or something. Let me check. 101.325, okay? They ask for units of measure. Again, this is volume, right? So volume is measured in cubic feet. All right. Here's the last one. Last one is a little bit tricky. It's related rates. Here we go. So they tell us that at a particular moment where the height is 5 feet, the height is increasing at a particular rate. In the end, they want us to find the rate at which the volume of the water is changing with respect to time. I'll highlight that, okay? Find the rate at which the volume of water is changing with respect to time. Okay. The rate, so the rate is d of the water, so dv, the rate at which the water is changing, the volume of the water is changing with respect to time. So we're looking for this. Okay, so let me go back to part C. V of h, volume, is pretty much the integral of f, okay, from 0 to whatever height you guys want. Now, if you're confused about the x is like a placeholder. It really doesn't matter. It's a dummy variable. But if I integrate this, I'm going to get v prime of h is equal to f of h, but with respect to h. Okay? Actually, let me go back a little bit. If I take the differential of v, I get dv here. Okay? So I divide every differential by what I want. So remember, I want dv over dt. Okay. So they want us to find it exactly when the height is 5 feet. So that's going to be f of 5 times dh dt at t equals 5. Now they tell you what the rate of the height is at that moment. It says that the height of the water is increasing at the rate of 0.26 feet per minute. So increasing just implies that it's positive. So this is going to be f. This is going to be f of 5 times a positive 0.26. Okay, now what's f of 5? You just got to plug that in for me using your calculator there. Plug and chug, you should get your answer. But going back to that very last part of that question, they ask you indicate units of measure, right? Okay, so just think about it. You just found dv dt. How do you measure v? That's something cubic. How do you measure time? Now, what time did we use here? Okay, notice how we used minute. So this is going to be cubic feet per minute. Okay, even if you guys had no idea how to do this first part of the problem, you should always go for those easy points. Okay, so get whatever you can. That's it.